Ladies and gentlemen, when we talk about India's space exploration, sky is clearly not the limit. After the success of Chandrayaan 3 and Aditya L1, all eyes are now on the next big mission, the Gaganyaan mission. India is attempting to send humans into space, 3 humans for 3 days in an orbit of 400 kilometers and a landing back on Earth in Indian sea waters. A few days from today, on the 21st of October, the first test flight of the crew escape system will be held. It will basically check the safety of the Indian astronauts in case of an emergency. Remember, around 20 major tests, including 3 uncrewed missions, are planned before the big launch in 2025. Now, ahead of the first test flight, Prime Minister Narendra Modi today chaired a meeting to assess the progress of the Gaganyaan mission. PM Modi also urged the scientific community to set 2 major goals next. 1, a Bharatiya Antariksh Station or an Indian space station by 2035. And 2, sending the first Indian to moon by 2040. After the meeting, here's what ISRO Chief S. Somnath said. Listen in.
There's a flight test there happening on the Gaganyaan mission. So what do you have to say? How are the preparations going on for that?
It's going very well. We are going to have the launch on 21st, so early morning. So that will be a launch to test the crew abort system to make the crew safe. Now, TVD1 is a vehicle to test the abort capability of the vehicle. Abort is when something goes wrong in the vehicle, we'll be able to save the crew for that.
Now, with that in context, let's quickly tell you a bit more about Gaganyaan. First of all, the total cost of the program. The total cost is about 9,023 crore rupees. What about the components of the Gaganyaan flight? Well, the main parts include LVM-3 rocket, which is going to be the launcher, HLVM-3, which is the main body that consists of crew escape system, crew module, orbital module, and the service module. Now, the 3 humans who will be sent on the space flight are from the Indian Air Force, and as we speak, they are currently under training in Bengaluru. They've also been sent to Russia for training. So what are the steps that are involved in sending humans into space? The challenges that come with it, and the big goals for 2035 and 40. I talk about all of this tonight with my guests. Let me first introduce them to you. I'm joined by Mr. Manish Purohit, who's a former ISRO scientist, and Mr. Girish Linganna, Aerospace and Defense analyst, also joins us tonight. Good evening. Thank you very much, gentlemen, for joining us tonight. First to you, Manish. This meeting of the Prime Minister on the review of Gaganyaan comes ahead of the first test flight that we are about to conduct on the 21st of October at 8 in the morning from Sriharikota. Help us understand what is going to be happening during this test flight. What are we going to be checking? What are the things that we are looking at when we are checking whether our astronauts will be able to escape in case of an emergency?
Thank you, Shreya, so much for the opportunity. Actually, the test on 21st of October is the test of the system that is meant to safeguard the crew if in case something goes wrong with the launch vehicle. There are different possibilities that can happen. The number one is when the launch vehicle with the crew on board is standing on the launch pad and say some leakage happens or something happens with the launch vehicle. And that has happened in the past with the Roscosmos, with the Soviets. Russians have seen that thing happening and the launch vehicle caught fire. Now, in that case, when you are sitting on a launch vehicle just carries fuel, nothing else. It's all completely filled with fuel, means something that is going to burn. But if it is going to burn uncontrollably, then it will be an explosion. In that case, the only priority is to safeguard the crew. Now, this crew escape system, CES, is meant for that only. So what we are going to do this time is, we have designed a very specific launch vehicle. The first phase of GSLV Mark II uses liquid Vikas engine boosters. We call them L40. L40 means it is for 40 ton, 40,000 kgs is the mass of that booster. We have redesigned it to look like a first stage launch vehicle, single stage launch vehicle. On top of it, we have fitted the crew escape module. Now, when on the 21st of October, it will be ignited, there will be a liftoff, and when we'll reach an altitude of around 11.7 kilometers, anomaly will be created. It will be created intentionally because if something goes wrong in the real flight, then what is going to happen? But we can't wait for that. So we have to test it in these demonstrations. So anomaly will be created. That can be like, something going wrong with the launch vehicle, it is going off trajectory, it is spinning, something is going wrong with the launch vehicle. In that case, how quickly and how perfectly our crew escape system performs. Now, what happens in the crew escape system is there are solid boosters, solid motors are there. Those motors will start, they will ignite automatically once they sense that there is something wrong in the trajectory or something is there which can harm the crew on board. They will produce enormous thrust and they will guide the crew module totally away. If you've seen those pics, the viewers might have seen the pics where we have a single stage. On top of it, we have kind of a rotor type of a structure is there. That's the crew module, and on top of it, we have a tower kind of a thing. On those towers, we have 4 nozzles that can easily be seen. Those nozzles, they are called LAMP, low altitude escape motors, and then there are high altitude escape motors. They will be ignited, they will generate huge amount of thrust, and they will steer away that particular module, crew module, away from the launch vehicle that might, undergo some accident or might some mishap may happen. Now, this is just one of the tests. Already one test has been done that is called pad abort test that has
Okay.
already been done, that has been tested. And there are few more tests planned because this is the mode 1. Then there is one more mode when we are at an altitude beyond 70 kilometers. Then what will happen if we are approaching the orbit and upper stages fail? Then what will happen? So there are different tests planned for this because the only priority and the topmost priority in human space program is if you are carrying astronauts, you have to bring them back safely.
Yeah, absolutely. Okay, Girish Linganna, 12th April 1961 is when the first human went into space, and we all know that human by the name of Yuri Gagarin. Years later, India is attempting to send humans into space. Why does it mean so much to us? Why is it so significant to us, considering the fact that, yes, we have sent Mr. Rakesh Sharma earlier as well, but he was not on an Indian space flight. He was on a Russian space flight. He was a cosmonaut. But today, in 2023, why does it mean so much for us? What is the significance of the Gaganyaan mission in the context of the kind of strides that India is making in its space exploration?
See, this is the first time we are attempting to send human to the space. That is the first challenge what we are facing. Means, as Mr. Purohit told, there will be there might be a lot of issues during the ascent or even during the descent phase. Why I am telling during the descent phase also is because as the spacecraft enters the atmosphere of the Earth, there will be a friction between the body of the spacecraft and the Earth atmosphere, where it can go to somewhere around 1000 to 1200 degrees centigrade. So the spacecraft should withstand that high temperature and protect our astronauts who are inside that and should safely bring them down. That is the biggest challenge we are having. You can see in Kalpana Chawla case and all these people who got burnt out while re-entry phase. So that is where it's a challenge for us to re-enter the vehicle. That is where India is preparing so much for the Gaganyaan mission. Once we are through with the Gaganyaan, then we are confident that we have made a re-entry space vehicle foolproof, and then we can go for attempting more and more heights.
Okay. Manish Purohit, I want to understand from you, simplify for us, when an astronaut does go into space, what are the kind of challenges that we as human beings face when we're sent in that space flight?
Yeah, during the ascent phase, when we see the liftoff, that time the force with which the Earth pulls us, that's the G force. When an astronaut is going into a liftoff phase, then this G force increases and it becomes so huge that even scratching your nose can be an issue. It becomes so huge, means it's like
So
your
by
weight will
G-force, you
increase
mean
3 4
gravitational
times.
force, right?
Yeah, so we call, yeah, that's a gravitational pull that you will
Okay.
feel because of your motion. So that's because of Newton's laws of motion. So it's kind of a pseudo force that you feel when the launch vehicle is going up with high acceleration. So we feel the opposite force, that is downwards force we feel, and more the acceleration of the launch vehicle, more downward force we'll be feeling. So it's like, if you're in an elevator and you're standing on a weighing machine, if elevator is accelerating upwards, the the weighing machine in the elevator will be reading more weight. Let's say if I'm 60 kgs and if I'm standing on an weighing machine in an elevator and elevator is accelerating upwards, weighing machine will be reading 70, 80, something like that. So same thing will happen, but on a bigger scale, like 2G, 3G, means twice your weight. Twice your weight you will be feeling if you are an astronaut and you are in the vehicle when it is lifting off. First part. Second thing is, gradually when you are moving out, then there will be a lot of vibrational loads are there. Jitters will be there, and they will be huge. That's why the whole of the design of the launch vehicle is qualified for the human space program. Our LVM-3, which it was already having all those liquid stages, cryo stages, and solid boosters, but everything has been re-qualified for the human space program, because putting a satellite and giving the vibrational load on the satellite is totally different when while you are sending an astronaut, a living being. There are limitations on our body. So this is the part of the liftoff. Apart from that, once you enter into the zero G, then the whole thing changes, because in zero G we are so much used to the gravitational pull of the Earth that everything that happens on Earth is so gradual for us. But once you into the zero G, even the water will not fall down. Even you wring the clothes, the water will be lying there on as a layer. So things are totally different. So you have to be accustomed to that particular environment also. And the most interesting aspect of being an astronaut and in the zero G space, microgravity space, is when the Earth is not pulling you down, then our head is resting on our bones here at the joint, and that is getting pulled down. Now, what will happen when you are in a very microgravity space or zero G space? That downward pull is not there. So that's why astronauts may start losing, or if they are staying in the zero G space for the extended duration, they start losing muscular mass. So they have to do regular workout when they are in the zero G space. So most of the time we have seen in the International Space Station, those astronauts who stay there for extended durations for 100, 150 days, 200 days, they do regular exercises to maintain that thing also. So these are the few things. Apart from that, obviously, if you are staying there for a longer duration, then you have to carry your food, you have to carry your nutrition, all that things comes up. But while the astronauts are being trained, they are trained for all these peculiarities. Right now, our astronauts who have been trained in Russia, they have undergone a general training where, gradually the air pressure has been reduced, and then they are asked to do some very simple jobs like just make some actions like that, just clap and clap like that. These are the few actions that they are asked to do, and gradually the air pressure is brought down and their oxygen masks are removed just to check how much control they have. And when they start losing it, when that thing, the oxygen level goes down, how they start deviating from the given task in the orders. So these are the things. Then there is one centrifuge system in which there is a big road, and at the end of the road there is a cabin in which astronauts or cosmonauts are made to sit, and then that centrifuge starts rotating at a very high speed to give them a feeling of 7 times the pull of gravity, 8 times the pull of gravity, and that time they are asked to do some very simple jobs like writing a simple code or doing some simple solving simple puzzles. So these are the part of the training that they undergo. And why they are doing all that? So that they are
Manish, do
ready
you
for
also
the
think that there are
peculiarity.
also psychological issues that could hamper, their stay in space? Because isolation is one of the biggest issues and challenges that our astronauts might face there. Do you think behavioral issues like sleep disorders, fatigue, depression, all of this comes in? And how does one really cope with it then?
Yeah, actually, see, if you talk about the sleep disorder, let's take an example of International Space Station. On International Space Station, in a single day, there is multiple sunrises and sunsets because it is going really fast and it completes the journey in around 90 minutes around the Earth. So there are multiple sunrises and multiple sunsets. Means our sleep cycle, which is completely aligned with the sunrise and the sunset, completely goes over. It completely goes haywire. So you have to train yourself for that. And other part is, the psychological part is they are trained. They are literally they are educated about that. Classes happen, semester-wise courses are taught, and they are given out those practice things are given to them, and they are asked to stay in such environments where they will be monitored, they will be checked, they will be tested. It's like they are made to stay in a secluded chambers also for a time, and they are completely observed that how their behavior changes, because once you are in space you have to work as a team. You can't afford to have any behavioral changes. Any compromise up there can compromise the whole mission.
Okay. Girish Linganna ji, the Prime Minister today also set a target for the scientific community of the country. 2035 is when he said that we should be looking at establishing a Bharatiya Antariksh Station, or the Indian Space Station, and by 2040 we should be sending a human being to the moon. Do you think India has the wherewithal, the setup, the infrastructure and the resources to work in that direction right now?
Yes, we are. That is the Gaganyaan is the stepping stone for all these things. Once we do the successful of Gaganyaan, then we are confident that we can send our crew to the about 300, 400 kilometers away, set up the station, come back, cargo transportation. All this is a challenge to set up a space station. So this Gaganyaan, I think it will become a stepping stone for doing all these things in future. So we are working more on this Gaganyaan, and I see this will be a successful mission. I'm sure with the number of tests what they are taking and the safety precautions they are taking, they will definitely see that like Chandrayaan, this also will be a success. Once we are success, that like re-entry is successful for us, that a human is brought back safely from the space, then all these things will start automatically. Even this gives a push to do all these things automatically.
Okay, my last question to you, Girishji. If and when India does that and we complete this successfully, we will be the fourth nation in the world to do so after US, China and Russia. Right now, as we walk towards that and as we work towards it, are we doing anything differently from these three countries in the Gaganyaan mission, or are we following the same format?
No, we are not doing anything differently. I don't find anything differently we are going to do. But of course, we are trying to improvise on the mistakes, what they have done it. Probably we have got more of inputs so that we will be more, our design will be more safer and safe. I can say that. So there won't be anything other than that. Probably in the material or the coating of the spacecraft, all these things may improve, because earlier they were using tiles, but now they are using a material called Kevlar, which will be a very heat-resistant material. Probably there will be an improvisation. Definitely there will be an improvisation, but the basics will be taken from already what these people have done.
Okay. On that note, let's hope for the best. It's a long way for India to complete this mission successfully, but we have our fingers crossed, and of course a billion prayers as usual with the Indian scientific community.
So
we hope that India is successful in Gaganyaan mission.
After Gaganyaan, the next is we have to build up a more powerful launch vehicle if you want to send human to Chandra, like moon or anything like that. That we are still lagging behind.
To the moon.
We have to build up a stronger spacecraft. You cannot take 40 days to go to moon at that time. You should reach in 3
That was
days
also the
or
part
2
of the
days.
discussion.
All these things, you need a powerful rockets. All these things we
Well,
have to develop.
They're
Probably
calling it
we are
next
moving
generation launch vehicle.
faster now.
Yes,
They're calling
yeah.
it next
But I
generation
think
launch
all of
vehicle.
us will
It will
agree
be
right now
powerful.
that we...
There is a impetus
Okay.
for this.
Okay.
I can say we are moving fast on these things.
India is working on next generation of engines also. They are called semi-cryo. They are under development right now. That whole thing has been set up. They have the
Okay.
whole facility and the tests have been done. So that will increase our launching capabilities, the payload that we can carry. Because if you are talking about Bharatiya space station or taking the astronauts to the moon, then we
Yeah.
need heavy lift-off launch vehicles. Heavy lift-off means the Apollo mission had the launch capability taking the payload of 95,000. The launch vehicle was able to take 95,000 with it. That launch vehicle was around 27 lakh kgs. Right now, our LVM-3 is 6 lakh 40,000 kgs. It can carry only 4,000
Tons.
kgs of
4 tons.
payload.
Yeah.
So we have to work on our capabilities also if we
Okay.
are planning to go to the moon and beyond.
Okay, yes. I think we're a country of aspirations and, no harm in having scientific aspirations and hoping to succeed in them. We have proven it in the past and hopefully we will prove it in the year that is leading up to 2025. And I'm sure all of us will agree that India has come a long way from carrying a rocket on a cycle to now even thinking and planning and working on sending humans into space. So let's hope for the best. We will, of course, keep meeting in the course of time and discussing India's progress on the Gaganyaan mission. But for now, thank you very much to both of you gentlemen, Manish Purohit and Girish Linganna. Thank you very much for joining us on Mirror Now and sharing your thoughts on the Gaganyaan mission, India's big space dream.